Hello everyone, I am Sriharsha NK, currently pursuing my engineering studies in Electronics and Communication stream from NMAM IT NITTE. I am here to present my internship project, but before that, I would like to take up this chance to thank Emertxe Technologies for providing me with this wonderful internship opportunity. And I would also like to thank Jayalakshmi Madam for guiding us throughout the project. So, without further ado, let's dive into the contents of this presentation. The contents are as follows. We start with a brief walkthrough about things we learned, which basically includes introduction to C programming, which was taught to us from scratch, then IoT, Internet of Things, fundamentals of embedded systems, and the microcontrollers which we used. The next part of this presentation includes about the project we have undertaken in this internship, which, which basically contains overview of the project and the objectives of the project which we have tried to accomplish, the design elements of the project, simulation, and finally conclusion. The C language is a general purpose, widely used and high level language. The picture indicates a simple program to print a hello world in the output window. As it is labeled in the picture, this indicates the file header, and this hash include stdio.h is known as preprocessor directive. Here stdio.h stands for standard input output header file, and int main marks the start of the program. This int main can also be written as void main, and this slash and stars are used to indicate the comment written in the program, which intimates the programmer or the user about what the program does. And as usual, this is the printf statement, which prints the statement in the codes in the output window, and return 0 marks the program termination.
These are the topics we have learned in C. First one comes to be data types, modifiers and qualifiers. Basically, data types are classified into two types: primitive data types, derived data types. The examples are primitive data types comes to be int, char, float, double, etc. And derived data types comes to be arrays, structures, pointers, etc. The modifiers are said to be short, long, signed, and unsigned. We have used unsigned in most unsigned modifier in most of our programs. Here, unsigned means the variable can only hold positive values. The next one is operators. Operators can be bitwise, logical, arithmetic, etc. And we have also learned about creation of arrays and pointers. Then we have also learned about functions. Functions is a block of code which is executed only if they are called either in the main program or in any other function. Then we have also seen about storage classes in brief, which describes features of the function, and then preprocessors. This is the brief about what we learned in the classes. Next comes Internet of Things, collective network of connected devices, which basically means collective network basically means linking.
Here different devices are connected over the internet with each other through a cloud, which can be seen in the picture. It depicts that statement very beautifully. Technology that facilitates communication between devices over the internet. As I said, basically Internet of Things, in Internet of Things, devices are connected over the internet through a cloud, and they communicate and exchange data between them to facilitate certain applications. IoT systems works through real-time collection and exchange of data. That is, IoT systems collect and exchange data in real time to successful to, to achieve successful operation. And these are some applications and examples of or examples where Internet of Things are used. So applications come to be in automobile industry, manufacturing industries, logistic and transport, and for business purposes, Internet of Things is widely used. Some examples are wearable health monitors. To be specific, pacemakers can be a specified example. Smart cars, mm, the recently launched Tesla cars.
Home automation, and this is the project we have undertaken, which we will be speaking more about in the upcoming slides.
The next topic we learned is about embedded systems, combining computer hardware and software to perform a specific function itself creates embedded systems. As you can see in the this is the block diagram of a basic embedded system, which consists of sensors, analog to digital converters, processor and ASCII, memory elements, memory or storage, digital to analog converters, and actuators. From sensor basically takes the required input from the nature, as all the signals present in the nature is analog, and microprocessors or microcontrollers only understand and machine language, which is digital. We need to use analog to digital converters, which converts analog inputs or analog values to digital values, which is then fed to processor, and this processor performs the required operation on the digital inputs which the analog to digital converter provided, and the required information or the important information is stored in the memory element.
The output of digital to analog converter is fed to the actuator, which compares the output of digital to analog converter with the expected output.
Embedded systems are low cost and low power consuming small computers which can be embedded in various mechanical or electrical devices. Generally, they comprise of a processor, power supply, memory, and communication ports for communication with other devices. These are some applications and examples of embedded systems. As it is mentioned in the picture here, embedded systems has variety of applications in different fields of engineering and also in medical field. Engineering fields include electronics, robotics, security systems, telecommunications, automotive industries, and also in medical fields.
Some of the examples include CAT scanners, implanted heart monitors, electric vehicles, household appliances, and many more. Here, CAT scanners and implanted heart monitors come under medical field. The next topic we came across was about microcontrollers. The major components and things present in microcontrollers are ADC block and DAC block. ADC block or ADC stands for analog to digital converter block, which basically converts analog values to digital values, and DAC block, that is digital to analog converter block, does the vice versa operation, that is converts digital values to analog values. Then comes timers and counters. Timers are a device that counts down from a specified time interval and is used to generate a time delay, while counters are devices that store the number of times a particular event or process occurs with respect to clock signal. Then we have also seen about PWM, that stands for pulse width modulation, and we have also seen about and learned about processors and memory and input output ports of the microcontroller, and in memory we have learned about registers and other important elements. We have seen the difference between microprocessor and microcontroller. The major difference is microcontroller puts the CPU, that is central processing unit, and all the peripherals on the same chip onto the same chip, while microprocessors houses a more powerful CPU on a separate single chip that connects to external peripherals and enables powerful processing. Next, we have also seen about RAM, ROM, and its types. Here, RAM stands for random access memory, and ROM stands for read-only memory. There are, for instance, let's consider RAM. There is static RAM, that is static random access memory, which stores data as long as the power is supplied to the transistors present. Which it is basically it is it consists of 4 to 6 transistors. Then comes dynamic RAM. It is commonly used as a main memory of the computers. For some examples for ROM and or its types of ROM can be said to be erasable programmable ROM. That is erasable programmable read-only memory. It's a non-volatile type of memory, but it erases the contents present in it once when it is subjected to UV rays or ultraviolet rays. One more example is electrically erasable programmable ROM. It is the same type. It is of the same type of erasable programmable ROM or EEPROM, but the only difference is the contents in EE, that is electrically erasable programmable ROM, is that it erases the contents present in it when it is exposed to electric charge. This slide speaks about this slide contains the overview of our project. Our project basically provides an IoT-based home automation solution using Arduino Uno board in PixSimLab simulator, that is a software simulator which contains different types of boards, and we have used Arduino board with 80 mega 32 microcontroller. We have also used Blink IoT mobile application to use which is used to control the devices remotely, and we have tried to control the lights, temperature of the home, that is temperature sensing,
of the home, and water tank control. You have to try to control what the volume of the water tank.
What the objectives of the project are. We have decided on main three objectives. First is to connect all the home appliances to Pixim Lab and integrate it with Blink IoT app using Blink Cloud. Second is to achieve total control over the lights, temperature of the home, along with the level of water present in the water tank using the mobile app, in this case Blink IoT app. The third objective is to obtain a notification about the status on the mobile phone, about the status of the home on the mobile phone. Okay, I spoke about on how we will automate the home appliances, but why do we require home automation? Happens to be the fundamental question we need to ask ourselves. A, a house becomes home when there are people living in it, and people use various gadgets or appliances to make their lives easier, faster, and productive. Now, it is not in the ideal case that everybody stays at home every time. There are some unavoidable circumstances where people have to leave the home for certain period of time or for a long period of time. So this brings us to the problem of home appliances not being monitored. So the solution for this problem comes out to be home automation. So this is why we require home automation. Home automation enables people to control most of the devices remotely from wherever they are, and a few of the devices which can be controlled as such are volume of water present in the tank, garden lights, and temperature of the home. There are still other more devices which can be used and which can be controlled, but these examples are what we have tried to control you in our project. We have used Arduino Uno board in this project. Arduino Uno is a microcontroller board based on 80 mega 328P. It has 14 digital input output pins where 6 can be used as pulse width modulation outputs and there are the next 6 input as input output pins. It also comes with the 16 megahertz ceramic resonator and a USB connection. Arduino Uno boards can be programmed using different IDE, that is Integrated Development Environment. We have used Arduino IDE in this project. Arduino IDE supports C and C++ languages. Next, we have seen a tool called Pixim Lab Simulator. Pixim Lab is an open source real-time emulator of development boards with integrator MPLabX and debugger. It supports some Pixim microcontrollers and some SIM-AVR microcontrollers. It has integration with IDE for programming the board's microcontrollers. This is the picture which basically shows the layout of the Pixim Lab simulator. In this simulator, we can load the hex file generated from the Arduino IDE to simulate our projects and see its operations. This slide speaks about Blink IoT app and its configuration. We have learned how to create a new template, how to add a device, how to add and select a data stream, how to create an icon and widgets, and how to include Blink library. Basically, we have learned we have how we configure Blink IoT app in mobile and how the system is connected to the cell phone using the unique code mm, for for our system from Blink IoT platform. Now let us see something about LDR, light dependent resistor, which can be used as a sensor which detects the light that falls on it. It is also known as photoresistor or dark detector LED. The resistance of a photoresistor decreases with increasing incident light intensity. This, the same is shown in the graph here. This graph shows the gradual decrease in resistance with increase in light intensity. The LED lights are connected to LDR via ADC. The analog digital converter converts the analog input by the LDR to its equivalent digital form. Then it is converted by a certain formula from 0 to 255 as upper bound, based on which we decide whether to switch on the LED or to switch off the LED. Garden light control. This is the objective we have tried to accomplish in our project, and the properties of LDR sensor we have seen in the previous slide is applied to accomplish the controlling of garden lights. This this picture says most about it. The LDR sensor mm, sends the or detects the light and provides analog input which is converted to digital form, and it is fed to the Arduino Uno board which has the microcontroller in it, which decides whether to switch on the light or switch off the light depending on the intensity of the light, depending on the input provided by the LDR sensor. That is, during the day, the outdoor light is maximum, so LDR sensor detects the light and the garden light is turned off. Whereas at night, the outdoor light is very low, so LDR sensor detects that the intensity of light is very less, and thus the light is turned on. The next topic is the temperature sensor, which is LM35 sensor. It is a 3-pin device which records the temperature value directly from the nature, which is analog. The analog value is then converted into binary value, and actual value of temperature is calculated using the obtained voltage. It does not require any external calibration, and what we need to do is just supply the input voltage in the range of 4 to 20 volt to its pin 1, and it provides the required output. Its temperature range is over minus 50 degrees Celsius to plus 155 degree Celsius with the accuracy of plus or minus 0.5 degrees Celsius. The output scale factor of the LM35 is 10 millivolt per degree Celsius. That is, for instance, if the output voltage is 250 millivolt, it indicates that the temperature is 25 degree Celsius. Temperature control system. This is the second objective mm, of our project, and we have used the principle of the temperature sensor, principle and properties of the properties of the temperature sensor to accomplish this objective. The temperature
control system consists of a heating resistor and the LM35 sensor and a cooler. The analog value of temperature is obtained from the nature using LM35 and it is displayed on CLCD after converting it into digital value using analog to digital converter. This temperature is controlled using the Blink IoT app by turning on or off the heater and the cooler. This block diagram depicts the working of our project based on this objective. The heater control and cooler control mm, are provided as inputs to Arduino Uno, which basically we can which is basically we can control by turning on or off the switches in the app, and the temperature is written back from Arduino Uno or the microcontroller in the form of notification, which is also displayed on the CLCD. This block represents temperature system, which has the heater and cooler systems present in it.
The third part of our project is water tank inlet and outlet valve control. The volume of the water present in the tank is read through serial communication and is displayed on the CLCD. The volume of the water is controlled by controlling the uh, inlet and outlet valve by sending commands through the serial communication, which is and the volume of the water is displayed um, on the CLCD as well as in the Blink IoT app. What we have done here is we have set the minimum value of volume of water present in the tank to be 1000 liters, and the maximum value on of the volume of water present in the tank is 3000 liters. The 3000 liters indicates that the tank is full, and the wa- and 1000 liters is the volume of water below which the inlet valve automatically turns on, and we receive a notification about the same through the app, and it is also displayed on the CLCD. By this, we ensure that tank is full and ready for any emergencies. The procedure or the function I explained just now is depicted in this block diagram. This is the This is the simulation image of our project. This image basically shows all the components we have used in the project for our simulation: the cooler, garden LEDs as garden lights, heater, LDR sensor, and CLCD display for notifications and other stuff. And more about this and the simulation video will be seen in a few minutes. This is the conclusion we have arrived at. In summary, this project provides a solution of monitoring and controlling the home appliances and certain devices remotely, which is the which is a solution offered for the problem statement we had in our hand. Using Blink IoT application and Pixim Lab simulator, home automation project is simulated where LED, temperature system, and serial tank um, resembles the garden lights, heater and cooler of present in home, and water tank in real time. So Blink IoT application allows the user to control these devices according to their wish um, from anywhere from anywhere in the world uh, using Internet of Things. Thus, we have accomplished home automation. Now, the simulation video will be demonstrated and explained by my teammate. Thank you.
Okay, this is a code which we have used in our project. This part is for IoT app, IoT Blink IoT authentication, which helps us in monitoring our code from mobile. Uh, the first part in our code is for uh, temperature system that is given here, and when the temperature is greater than 35 degrees Celsius, that is here, the heater should turn off because that is not normal for room temperature. And when temperature is less than 28 degrees Celsius, that is the actual room temperature that is shown here. The cooler should turn off here. That is the second part of our project, temperature system. And third last part of our project is about serial tank. When the tank volume is less than 1500 degrees Celsius, that is what we have taken in our project. And when less than 1000 degrees Celsius, the inlet should automatically turn on. And a notification should pop up saying that inlet valve is the water level is less than 1500 liter, so inlet valve is turning on. The maximum level is here 3000 degrees Celsius, 3000 liters, and when tank reaches the 3000 liter, the inlet valve should turn off. And whenever we turn on the outlet valve, the water should flow in opposite direction. Okay, first part of our project is about garden lighting. This is the LDR. When resistance of LDR is very high, garden light should turn on. That means it is a night time and LEDs will glow. Uh, Next, when we decrease the resistance of LDR, the light should slowly turn off. As we can see now, the light is turning off and it is completely off now. This indicates that it is daytime and LEDs will turn off. Next part of our project is about temperature in a home, and as we can see, this is our Blink IoT app which we are monitoring with our mobile. And when I turn on heater, the temperature should go till 35 degrees Celsius. When temperature is greater than 35 degrees Celsius, the heater should turn off, and we should get a notification in our mobile screen saying that the temperature is greater than 35 degrees Celsius, and heater will turn off automatically. Now if I turn on the heater, yeah, as we can see, the temperature is increasing slowly, and when temperature is greater than 35, it should turn off. Yeah, now we can see that the temperature has turned off, and a notification is appeared here saying temperature is greater than 35 degrees Celsius, and heater is turning off. Now if I talk about cooler, when I press this cooler button, temperature should fan is rotating now, as we can see, and temperature is decreasing. The cutoff for temperature is 27.9 degree Celsius. At that time, at that point of uh, at that temperature, the cooler should turn off and notification should appear here. As we can see, notification also appeared here, saying that the cooler has turned off because it is a normal room temperature. This is about our temperature sensor project. That is the second part of our project. The last part of our project is uh, about a cereal tank, and in the cereal tank, the maximum volume of water which it can store is 3000 liters. And now, initially, I have completely filled the tank. That means it is completely filled, and 3000 liters are filled here. Inlet is currently off as it is completely filled. Whenever I turn on this outlet, the water should flow in opposite direction. That means it should empty the tank. If I turn on this, uh, yeah, as we can see, the water is decreasing. The cutoff what we have taken in this is 1500 actually. That is what we have made changes in our code. Uh, uh, and whenever it reaches below 1500, yeah, it reaches below 1500, the inlet should turn on. As we can see, the inlet is turned on now, and a notification has popped up here saying that water level is less than 1500, and inlet has turned on. Now I cannot turn off the inlet now because it has already reached the cutoff. Now if I turn off the outlet, it should increase again. As you can see, the water is increasing here, and notification will pop up here saying that the water is completely filled. Now if you see here, yeah, no notification has popped up here saying that enabled water level is 3000 liter water inflow disabled. Inflow is now disabled. Inflow will disable only when the water is completely filled or it is greater than cutoff, but below cutoff we cannot turn off the inlet. And now again, if we can turn on the outlet and we can see that water is flowing in other direction. And I can turn off the outlet now. Yeah, as we can see, inlet has not turned on now because the cutoff has not reached yet, and water level is, and we can see here water level is 2250, and that is about our project. Thank you.